What's up, guys? Today we're going to be solving 129 sum of root to leaf numbers. This is a question that you can find in many top 150, 75 lists out there in LeetCode, so it's super important to be able to understand the solution. Without further ado, let's jump into the problem. By the way, I apologize for the voice. I might sound a bit sick, and that's because I am sick, so just keep that in mind. Anyways, the main point of the problem is to sum up every root to leaf number in the entire binary tree. So for example, in this path, you would have 495, right? And in this path, you would have 491. And in this path, you would have 40, right? So the main point is to sum up all of these and return the sum at the end. In our case, it will be 1026. So while trying to solve this, I thought of a really cool way of doing this. And basically, what if we were to go ahead and propagate our answer down the tree until we go ahead and hit a leaf node? So for example, using DFS, starting at the root node, we'd have to add the right first, and that would go ahead and make us want to update this value to 40, right? And then we would go ahead and go on this side, add the left node, and that would make us go ahead and update this value to 49. So now when we go ahead and go to this node, we actually see a 49. And taking this even further, we'd go ahead and add the right node here, and we have a 49 and a 1. So this node, we would change it to a 491. And this node would be changed to a 495. And in our algorithm, we'll make sure to return every single time we hit a leaf node. And what do I mean by return? It would be to go ahead and have some sort of global variable, right? So every time we hit a leaf node, we just add it to sum, and then we return sum at the end of our problem. It's as simple as that. And we could go ahead and use BFS or DFS. I'm going to opt for DFS because I usually always do BFS, so I want to practice my DFS a bit, but you could use BFS. For those who don't know, DFS travels in this order, and that's it. The way we're going to go ahead and propagate our answer is via a simple algorithm. So I'm just going to show it for one root to leaf. So here, 49. At this point, it needs to be 49. So what we're going to do is multiply our previous node by 10 and add the current node. So 4 is our previous node. So we do 40 because 4 times 10 plus 9, and that would give us 49. Now, same thing here. We would take our previous answer, which is 49, multiply it by 10, which would give us 490, plus our current node. So it would be 495. So let's go ahead and look at our code implementation. I've already added the base case, so if there's no binary tree, then we return nothing. And I initialized our stack and appended our root and initialized our total sum variable, which is the global variable that we'll have to keep track of the sum. So first things first is we have to have our case when it's a leaf node. At that point, we have to add it to our total sum. Don't forget to also pop your node. So the next step would be to go ahead and add our right node and make sure to propagate our answer. And it would look something like this. Right, so this is our formula to go ahead and update our right node. So just the current node times 10 plus the right node's value, and then we append it to the stack like normal. For the left side, it's going to be exactly the same, just for the left side. And really, that's about it. So we just return our total sum at the end, and that's it. So let's just see how well we perform. So small little mistake. This is val. It needs to be val. And there we go. We have very good time complexity and pretty good space complexity. If this helped you guys in any way, shape, or form, please give a like and subscribe, and I'll see you in the next one.